Now in the last example, we picked any point we wanted to in each subrectangle. You could always do something like pick the middle point of each subrectangle, and that would be the midpoint rule. So for instance, let's look at R being the rectangle where x goes from 0 to 4 and y goes from 0 to 6. And let's estimate the double integral over that rectangle of the function x to the 8th over y to the 6th dA using the midpoint rule with m and n both equal to 2. So we're going to split up the x interval into just two sub pieces and the y interval into just two sub pieces. So first of all, here's the entire interval shown in yellow, and two sub intervals each direction, and we're going to just look at the midpoint in each of the sub intervals. So here it is, right? So from 0 to 2 in the x direction, the midpoint has x coordinate 1, and then from 0 to 3 in the y direction, the midpoint has y coordinate 1.5. Okay, and we won't talk through all of these, but these are the points. So we're just enforcing no choices because we said we're going to use this midpoint rule. In our earlier example with the airplane hangar, we made some choices on our own. So, the width in the x direction is 2 for each subinterval. The width in the y direction is 3 for each subinterval. The approximate area is 2 times 3 times. So we had just factored out the delta x and the delta y, right? So the approximate volume, is we just need to compute x to the 8th over y to the 6th at each of these 4 points. So you'll see here for the point 1 comma 1.5, 1 to the 8th over 1.5 to the 6th. And for this point here, 3 to the 8th over 1.5 to the 6th. And for this point here, this should say 1 to the 8th over 4.5 to the 6th, and then finally 3 to the 8th over 4.5 to the 6th. Okay, when studying integrals in an earlier calculus class, you might have seen the average value formula. So the average value of a function over the interval a to b is 1 over b minus a times the integral a to b of f of x dx. That b minus a happens to be the length of the line segment AB on the number line. What this models is, for instance, if f of x was a temperature x hours after midnight on February 1st, so for example, f of 2.5 would be the temperature at 2:30 a.m., then this average value integral represents the average temperature throughout the day on February 1st. Okay, so the thing is, in the blue box at the top, we divided by b minus a. Now we need to do something similar. Instead of dividing by the length, we need to divide by the area. So you'll see this times 1 over area of the region or the rectangle, and then double integral over r of a function f of x comma y. This is the average value now. The area of the rectangle represents, it's the thing that replaces the length of the interval. Interactive question, describe a scenario which could be modeled by the average value of f of x comma y. I think this is challenging. You're going to have to try to describe for yourself what x would represent and what y would represent and what z would represent in order to talk about this.